Okay, so what we have seen in the last session.
Clustering.
Clustering, right?
Clustering, one more thing is there now. That K cluster, I think.
Yeah, that's what I'm.
K means we done it. Hierarchical we have to do.
Yeah, hierarchical cluster. Okay, hierarchical. Right. So we'll just, here and there, we'll see just a basic the coding, and then we'll just go through the explanation. So we'll use to import the libraries and then importing the data set. Here, the data set will be different. It's a mall customers data set. So we'll see what is mall customer. And then dendrogram is this kind of hierarchical clustering technique. There is a terminology called dendrogram. We used to check what would be the clustering techniques which will, the data set is following. So first of all, we will, here you can see the cluster. I mean, sklearn.cluster. And from this package, we are importing agglomerate clustering. Just okay. So agglomerative clustering. This cluster, again, the number of cluster does matter a lot. Like how you are selecting the number of K, the same kind of things, the clustering. Cluster in the sense it's a grouping, categorizing, and whatever the term you are using, the same kind of a name using. And in this, the affinity is nothing but what would be the distance. We are calculating the distance, that is Euclidean distance, and then the linkage, what. So we are going to see about what is agglomerative clustering. Is there any other clustering techniques that is, that we are going to, have in that how we are going to select the number of clusters and what would be the impact on Euclidean? Already we have, done several, and we are using Euclidean distance in several algorithms. And linkage is very big. Okay. Right. So we'll first understand the concept. Okay. So hierarchy clustering technique is one of the popular clustering techniques. Right? Clustering is basically a technique that groups similar data points such that the points in the same group are more similar to each other than the points in other groups. So that's what I said. Yes, clustering is just grouping of data sets, and that is two. It is like similar data points. Okay. So the group of similar data points is called a cluster. So this is the original unclustered data. And this is just an example of cluster data because from this we are applying something and applying some concept. And after applying the concept, we are just segregating or grouping the data or grouping with respect to the similar data points. And we are making the differentiation. Okay. So differences between the clustering and classification regression models. So the same kind of classification we have done even in classification, right? But what would be the difference? I mean, what is the uniqueness with respect to the clustering? Okay. So in classification and regression models, we are given a data set which contains data points and class labels where yi is belong to 0, 1 or 0, 1, 2, and so on. I mean, they are just, discussing about the binary data set and the multiple information for classification models. And yi's belong to real values for regression models. This is the general concept of how classification and regression works with respect to the data set. Okay. But when it comes to the clustering, we are provided with a data set that contains only data points xi, this xi. Here we are not provided with the class labels. That means we don't get any kind of a yeah, they just consider this. Only this you will be getting. I mean, the unordered data set. We don't get any kind of a labeled information. So if we get any kind of a label here itself, we can segregate or we will be able to group it. So that is not the concept of clustering. So that is the potential of clustering techniques too. That is why we are going for the clustering because we are mostly dealing with unstructured information these days. So unstructured and also unclustered, right? So we are not able to do just like we're seeing the data set. So we are applying the concept of clustering, and then from that we are making into the cluster or order, or we are grouping with similar data points. That is what. So now, yeah, we are. So okay, let me just. Okay, here are two clustering techniques. That is, one is agglomerative, one is divisive. Okay. Agglomerative hierarchical clustering. Initially, each data point is considered as an individual cluster. At each iteration, the similar clusters merge with other clusters until one cluster or k clusters are formed. So wherever we are forming or we are, finding out the numbers. So wherever, finding out how many groupings or how many classifications, how many, whatever, I mean, the condition of, how many, there the k, the word k just, comes into this. So you can just observe from the starting point of when the k and then k means and everything, right? So here also we are, that is what the n underscore, the number of clusters it is just meant for. This is also, it's a k. Okay, finding out the k value. Okay, so at each iteration, the similar clusters merge with other clusters until one cluster or k clusters are formed. So this is what it is, how the k clustering or number of clustering is just getting formed. That means each iteration you are just giving the condition and you are checking, and it is just, forming, each iteration it is just, segregating the likelihood of the information or data points, and the similar data points just, getting into the classification, I mean cluster, and then it is just grouped together. Okay, so this is what each iteration it was just, happen. So yeah, the basic algorithm is very straightforward. Like if you see the code, it is very, very simple. It is just, merely, applying the conditions, applying the algorithm, finding out the k, and then distance, and then the linkage. So we'll just, it's very straightforward. There is no hidden like any other, even like, simple linear regression. Simple linear regression itself, there's too many concepts. Here it is not like that. So one is compute the proximity matrix, that's the distance, right? Let each data point be a cluster, and repeat, merge the two closest clusters and update the proximity matrix until only a single cluster remains. So for each iteration, this cluster is agglomerative cluster. It is just it is a kind of merging together. So it is just it is going to see the characteristics or features of the information or data points, and then slowly it is just acquiring the information and having the separate cluster. So the key operation is the computation of the proximity of two clusters. So what is the proximity? To understand better, let's see the pictorial representation of agglomerative. Let's say have 6 data points A, B, C, D, E, F. Step 1. The initial step, we calculate the proximity of individual data points in points and consider all the 6 data points as individual clusters as shown in the image. So A is a separate cluster, B is a separate cluster, and goes on until F clusters. So to our knowledge, it seems that it is it is an individual cluster. That means individual data points, like the same kind of information we have seen in the last algorithm. So the first iteration initially, we just as we had to assume that all the observations would be the I think what would be that information. Maybe we'll see that later on. Okay, so you have to consider or you have to assume in the first iteration itself, every observation on its own. Similarly, each data point has its own cluster. And then from, that is the first thing. That means we had to know each and every blue point is a cluster. Each and every blue points, that is data points. Okay. And then after each and every iteration, right, it is going to form, just consider this. So it is trying to get like, B, C are, similar or likelihood of the information, and D, E are likelihood, and then the F, maybe the next iteration, they are just forming a cluster. And then the B, C, D, E, F, they have formed one more clusters, and then all the A, B, C, D, F, this form the one more cluster together after merging all these information. So this is agglomerative hierarchical clustering process. So step 2, similar clusters are merged together. That's what we have seen and formed as a single cluster. Let's consider B, C, D, E as similar clusters that are merged, and we are left with okay. We again calculate the proximity of new clusters and merge the single clusters, and you have to keep the process just goes on. So calculate the proximity of the new clusters, and the clusters D, E, F, and B, C are similar and merge together to form a new cluster. And the process is just merge together. I think if you see the process B and C, D and E, and then D, E, F together, and then B, C, D, E, F together, and then A, B, C, D, E, F together. Okay. So the hierarchical clustering technique can be visualized using a dendrogram. Dendrogram is nothing but this is the dendrogram. Okay. So dendrogram is a tree-like diagram that records the sequences of mergers or split. Okay. So each split, it is just it looks like a tree, and it has all the linkage between the informations. Okay. So divisive, this is what the agglomerative. That's all about the process. So the divisive process, since the divisive hierarchical clustering technique is not much used in the real world, right? That is why we have the agglomerative hierarchical clustering example. So we don't have the divisive method because it is not that much used. So we can say that the divisive clustering is exactly the opposite of agglomerative. So in divisive, we consider all the data points as a single cluster. And in each iteration, we separate the data points from the cluster which are not similar. So it is just an opposite. Agglomerative, what we do, we just see the similar features. But here, in each iteration, it will just which are not similar. So each data point which is separated is considered as an individual cluster. So in the end, we'll be left with n clusters. So as we are dividing the single clusters into n clusters, it is named as divisive. Okay, so this is what the definitions it says, and so the calculating the similarity between two clusters is important to merge or divide the clusters. There are certain approaches which are used to calculate the similarity: minimum, maximum, group average, distance between centroids, Ward's method. So this is what we are using in this agglomerative. That is a linkage methodology called as Ward. Okay. So minimum, also known as a single linkage algorithm, can be defined as a similarity of two clusters, C1 and C2 and C1. And C2 is equal to the minimum of the similarity between points Pi and Pj, such that Pi belongs to C1 and Pj belongs to C2. So we'll see what is mathematically. So they are just discussing with these two diagrams. Okay. So the minimum value, how it is just calculated, that is what they are giving you. It's almost how what would be the minimum distance between these two clusters. Pros of minimum: this approach can separate non-elliptical shapes as long as the gap between the two clusters is not small. Okay, so it is separating non-elliptical shapes. That means all the similar data points. It is just separating together, and it forms very two clusters like this. You can see the shape. This is the minimum approach. So it is just to form some kind of a shape. So the minimum, the cons of minimum approach: cannot separate clusters properly if there is noise between clusters, like this. So it has to be cleaned data, shouldn't have any kind of outliers, right? If that is the case, then minimum won't work. So the maximum approach, opposite of minimum, but this is the maximum distance between the two two clusters. The max approach does well in separating clusters if there is noise between clusters. That is exactly opposite of minimum. Maximum approach is biased towards globular clusters. Max approach tends to break large clusters. Group average. So take all the pairs of points and compute their similarities and calculate the average of similarities. Yeah, that is the group average. That is a mean value of the clusters. Pros: the group average approach does well in separating clusters if there is noise between clusters. So you can maybe approach max and also group average if there is a noise. So cons: the group average approach is biased, again the same kind of cons like max approach. Distance between centroids. So compute this centroids. I think centroid concept we had discussed in SVM. Support with their missions. Okay, just how to find out the centroid, same kind of a concept. So distance between these two centroids as a similarity between two clusters. So this is less popular technique in the real world, especially for clustering technique. So Watt's method, this approach of calculating the similarity between two clusters is exactly the same as group average, except that Watt's method calculates the sum of square of the distances like Pi and Pg. Okay. So this is exactly like group average, but except that Watt's method calculates the sum of squares, and group average it is not. It is just taking the mean value. Here they are taking the sum of the square of the distances. Okay, so you can just see the information. So Watt's method approach also does well in separating clusters if there is noise between two clusters. So cons of Watt's method, the method approach is also biased towards globular clusters. So each approach, each method has its own pros and cons, but still it is a machine learning engineer's decision which method you have to use. And this is completely up to your experience, your expertise, so that your decision making is going to be an important methodology. Okay. So space and time complexity of, okay, this is different. Okay, the space required for the hierarchical clustering technique is very high when the number of data points are high, as we need to store the similarity matrix in the RAM. Okay, so here, I mean, from here onwards, we are dealing with um, kind of, if you apply this kind of an algorithm, how your computer or hardware infrastructure will be. Because, we are going to deal with all the other elements as well, like how is your RAM, how is your hard disk, how is your GPU, and everything else. Because it makes more sense, and you should have this kind of this, idea, so that while applying this kind of an algorithm, you also should consider where you are going to deal with. Are you dealing with the cloud server, or a physical server which is located in your office, or whatever the organization you are going to work on? So you have to check, and if not, if they are not following those kind of standards, you have to kind of you have to give a recommendation, because you should know as machine learning engineer, if you are applying this algorithm, please expand the RAM size, expand the GPU, expand, I mean, have the latest GPU version of the hardware, and you have to give this kind of recommendations too. That is your responsibility. You can't escape. And if you are running this kind of an algorithm, you should have at least, before running it, just measure the volume of data set. Based on that, you have to give the recommendation. If it is very less, that is fine. But anyway, it is going to be huge, because that is why we are using machine learning. There is no other. I mean, that is what the machine learning comes into place. So you should know the basic idea of hardware. Okay. So the space required for the hierarchical clustering technique is very high when the number of data points are high, as we need to store the similarity matrix in the RAM. The space complexity is the order of the square of n. So O of, I mean, order of n square, where n is the number of data points. So you can just calculate how the complex, I mean, space complexity works. Time complexity. Since we have to perform n iterations, and in each iteration, we need to update the similarity matrix and restore the matrix. The time complexity is also very high. The time complexity is the order of the cube of n. Okay. Space complexity and time complexity. So time complexity, order of n, n to the power of 3. So I don't know what is. Did you get any interruption in between, or is it continuous?
Yeah, we heard that recording is in progress. That's all.
Okay. Okay. Yeah. So this space complexity and time complexity. The limitations of this model: there is no mathematical objective for hierarchical clustering. All the approaches to calculate the similarity between clusters has its own disadvantages. High space and time complexity for hierarchical clustering. Hence, this clustering algorithm cannot be used when we have huge data. Okay. When you are dealing with millions and millions of data, better you won't recommend, or you don't do this on hierarchical. We have better algorithm. We can just, we are going to deal with. Either you can go for classification, in the classification itself, you can just, find out something. If you wanted to be, if they want to be very, very particular about this algorithm, then maybe the data set would be that much feasible. You have to check the feasibility of the volume of data. So that is one method. Now this is the implementation. Okay, so we know about the what, the Euclidean we already know, and how the number of, the same concept of finding out the k value, and this is agglomerative clustering. Okay, so you can maybe you can I will send out this. I think we have this, right? So you can just open it. Maybe you can change this number of clusters, and I wanted to see what would be the changes within, so that in that way you can find out, or you can just make a trial and error process. Okay, 5 would be the best option, or 4 would be the best option, or 3 would be the best option. So to find out the clusters, and if you just do the dendrogram, the same kind of how it is just getting linked to the tree kind of a structure, it shows based on the respective data set.
In the import step, should we change?
No, here itself there is a new thing. So import SciPy. This is not scalar. This is the SCI Python. SCI, I mean science Python.
Right.
So yeah, SciPy dot cluster. In that hierarchy, so you can maybe you can make it as a alias name for the easy identification or easy working with the program, and then you can just work on dendrogram equal to sch dot dendrogram. If you just give the dot dendrogram, it's just creating the dendrogram tree, how the data points are linked to one another, and you can have the differentiation. Okay, so if you give this, so you can, green is 1, purple is 2, yeah, red is 3,
When I
and
executed,
this one
color
is,
changed. Yeah.
yeah, yeah. So it makes it color combinations. So
The
if you
form
want
finally
maybe,
form a single cluster, like blue is a final single cluster.
here it
Blue.
is an agglomerative, right? So yeah, the final cluster is yes.
The cluster is
So
blue.
yes, exactly. So yeah, it is just combining together, because it is just form, and it is just this is the basic iterations. After each iteration, how it is getting transformed, or finding out the similar data points, and then it will just form by itself. Okay. So this is the method. Okay. But in my
Uh,
experience, we never used anywhere the hierarchy. Yes.
Mhm. What is the real world example, like where they use here? See, for example, you got the millennium data. Okay, that is a data type. But the real world
Mhm.
example where they implemented this one.
Okay.
Generally, the clusterings, or what we discussed last week, right? Now that
Mhm.
especially the the Zomato, Swiggy, and all, they're
Right,
using
right,
the
right.
K cluster
Let's,
clustering. Same way, I
yeah.
think how we are using the hierarchical clustering.
Yes, we'll see that. And then we need how we will be able to visualize those things. Given the real-time examples. Uh, I think in many cases, we are using. Um, I'll tell you, um, customer segment. Yeah, the customer segmentation. This is an e-commerce portal, right? Um,
Segmentation.
An e-commerce company might group its customers based on past purchase history. Not only the past purchase history, that is also based on, the history says that what the hidden meaning. It is also, how much amount you are spending, on what product you are spending, Is that a very frequent you are making an order, right? Yeah, the very next frequency of purchases and the categories of products bought. So this segmentation helps in creating targeted marketing strategies for different clusters. So this clustering technique will be used in the recommendation engine too, because many times we are discussing about once after you check out the Amazon or anywhere else, right? Even Flipkart or any e-commerce portal, it is giving you some other recommendation to retain you or to take a look at any other products together. Because the ultimate aim is they want to spend more time with their application so that to attract
This
and retain you as a customer. Yeah.
will help. I'm just thinking, correct me. Uh, for e-commerce, as you mentioned, but majorly like people will have something identified or favorites or wish list will be there.
Mm-hmm.
Um, Collecting that wish list data into one particular data set and then forming this agglomerate clustering. Um, that would help in suggesting different products because most of the time wish list you will have the item because it is not available in the stock or it is going to come soon but don't know when it is going to come soon. So those products also will be displayed in e-commerce, but if the customer is not patient enough, they need to also suggest them some other products. So their wish list is used to suggest different products.
Yes. That is also one of the use cases. Yeah, you can apply the agglomerate. Here it is a gene expression analysis. Mm, Don't have any idea how to visualize this. So whatever they are saying, we have to accept. So we couldn't see, or I mean, I didn't have that kind of if we have any kind of an healthcare or the life sciences example, we will be able to visualize because I worked on healthcare too. So this healthcare information is a different the gene expression analysis. Yeah, how might want to cluster genes that exhibit similar behaviors under certain conditions, like disease versus normal. So maybe what I thought, because I'm just making it as a R&D. I used to study this kind of information because how they are making a decision based on disease. If you are just going to the doctor just for the headache, and immediately you are finding it if you diagnose or if the doctor diagnose, if they wanted to make it as a scan, I mean full scan report or any kind of MRI scan or whatever it is, you are finding our doctor finds some other things. Okay. Actually, you are going for, you went for just a diagnose for your headache. But at the end of the day, or at the end of the diagnosis, doctor and also you found out that you have a different kind of a disease, and maybe that would be the hereditary issues or any, because there is no alarming point or there is no caution or there is no such kind of the impact on your day in and day-to-day life, right? You never felt those kind of a pain. You never felt. I mean, it happened. Many cases. So those things are normally would be point out to the how the behavior, how your genes behave at that particular age. You might not know whether your parents had, or you might not know your forefathers had, right? So how the transformation has become. So in those kind of things, this kind of an analysis, it is really helpful. That's
Mm.
what I am thinking.
Even this one, the stem cell saving,
Yes.
no? So they
Mm-hmm.
are actually segmenting the customer based on the genes behavior, like the possibility of disease. Like if there is any hereditary disease coming through, no, they can easily identify, okay, these genes, this type of genes have the probability of getting diseases. Like these are all they identify some diseases actually. So to
Okay.
avoid that, they are trying to save that stem cell. Okay, we can use that stem cell and we can replace if anything happen in future also. So that's they are actually projecting the marketing like that. So even yeah, I read an article.
Yeah, yesterday I met one of the fellow community members here, and he recently, just 2 days back, he had a surgery, and he had actually the back pain. So what they have done, it is not a surgery. Actually, it is not a surgery. But what I have done, what you said right now, the stem cells. They just extract the stem cells from the bone marrow, and then wherever you are getting pain, maybe L2. I mean, your spinal cord will have the order, right? L2, L2. I mean, the disc orders, L3, L4,
Lumbar.
or something. Yes, yeah. So those kind of things, wherever they are just injecting it, and after the injection, he has to. I mean, now he's taking bed rest, and he has to wait and see how does it work. It is not a surgery per se, but at the same time, they just extracted those stem cells, and then re-inject into wherever the weak points, wherever the weak bone was identified. That leads into a lot of other side effects, like who continuously his leg is getting pain, and continuously is having pain on the shoulders, in the arms, and so on. And it just goes on and on. And even because why we are discussing it is this kind of an analysis. It is a real time when you are going to apply your machine learning. And unfortunately, if he takes any kind of a processed food, right, immediately he feels sick. For the past 10 years, this is the case. And nobody, I mean, no doctor was saying that he has kind of an ulcer or something, nothing. His stomach is very, he doesn't have any kind of a disease in stomach. That is also proved. But he just took this kind of a processed food, and and now recently, I mean, the 2 days back, doctors were saying there's nothing in your stomach, and there is nothing you can eat processed food. Maybe this leads. I mean, this is because of this back pain. I don't know. Not sure, how it is getting related, because we are not sure that how uh, getting linked with the this um, back pain just got related with the food intake, or how it is getting connected with stomach. And maybe an allergy. I mean, when we can't say that it is an allergy, right? Not sure how it is. I mean, doctors is saying that they are saying that there's nothing in the stomach. I mean, there's no allergical kind of thing. They have tested each and every test what they have been through endoscopy. They have done, they have taken everything, but still he can't take up tamarind rice or something. The non-veg items like fish gravy, he couldn't take. Okay. And processed food, he couldn't take. The other kind of, whatever, yeah, these are all the things. But it doesn't seem to be an allergical issue. There is nowhere else, getting connected. Maybe he has to check maybe further days. So why I'm saying these kind of things also come maybe the hereditary analysis. So while you are analyzing, maybe in your life sciences data set, maybe you just take any kind of a sample, analyze to a clustering technique, and there are so many researchers are researching and how similar effect would be, you are getting. So I mean, this on a personal note, you can just try and check. Uh, Getting the data, that is the thing. But if you make out any kind of a synthetic data, that is really an awesome. Let's see. So that is also one of our product agenda in coming days. Synthetic data agentic. That means, like creating a similar data set what you are dealing right now in life sciences or healthcare or finance or whatever it is. So it is getting, that field is getting motivated, and that is why we are having the crunch of getting the data sets. So right now we are facing that too. So and that is one. Yeah, the document clustering for new categorization, fraud detection, document clustering. Maybe the for government process. There are so much of documentation processing in each and every unit. If you go for registration, land registrations, right? The flat registrations or plot registrations, whatever it is, right? How they are, how can they will be able to do the clustering? That is also news agencies like Google News Group, similar articles covering the same topic using hierarchical clustering. See, in Google itself, there are so many things we are not aware. Okay, so even I was getting surprised, whenever I was able to do the research, the basic research. Somehow Google is coming because they are already into those kind of things. Even for Python learning, they are having kids learning platform. Okay, so likewise, there are so many projects they are doing. Actually, we are not aware. So just try to explore, and we'll also, together we'll explore more things. There are so many things, so many researches. So yeah, that too in NLP. Okay. Hierarchy clustering is used in NLP to cluster documents or news articles. Okay. Fraud detection, yeah, credit card, bank, and everything. Image compression through computer vision. We'll see while learning the deep learning models. Social network analysis, hierarchy of product recommendations, crime data analysis, website visitor segmentation, market basket analysis. I mean, this is not limited to only these things. There are so many things. We need to find out the use cases. This is there is no limitations for any kind of machine learning. This is what you have to define. No, this is, the list is goes going on and on and on. So this is one thing. This is about agglomerative. Maybe you can. This is a very simple algorithm. There's nothing much about dealing with. So can we go to the next algorithm, or you can just try it out on your computer?
I just executed till this particular point.
This one, right? Have you changed anything? Any data?
So I'm changing. It is 5, right? So I am changing to 3 to see how it will differ. It is giving me error.
Okay. So what is the? Is there any other specific error?
No, unexpected keyword argument affinity.
Okay. Just give 4. Let's break it down. Maybe I will share. You can share your screen.
Yeah.
You can automatically share with me.
Yeah.
Because this is the enterprise edition. Let's try and
See, right?
No, we couldn't.
Why not see?
No.
Even 5 is not working, Sini, like the cluster 5.
Is it? Maybe indentation something, no? Some kind of.
It is like type error, it's saying.
Okay. Yeah, that is, I think that is a indentation error.
Now, can you see?
Yes, yes.
Okay.
Okay.
Same error.
Same
Yeah.
error. So,
Even if you put 5, so it will throw error.
okay. Okay. So explain error. Come to this section. It's same. I think affinity, if it in, it is not taking. Explain error.
Keyword argument affinity indicates
Is
solution
not
of scikit-learn evaluation.
Okay. Then what is the solution for this?
The change in
I
parameter.
think upgrade. Yeah. I think
Yeah,
it needs
right.
some upgradation.
So it is installing scikit-learn upgrade.
Okay. Just do that. I copy this. And then,
Why did it go to next page?
use code. Just copy the code and then use instead of. Just copy the code. Maybe I can just go.
No, it's not coming. Oh, here it is.
Yeah, here is code. Yeah. Oh, yes. Latest version. Okay.
Latest version.
This one.
Replace affinity with metric.
Metric. Okay. There is no affinity. So it was the older version.
Yeah, the term actually replaces affinity with metric. Requirement already satisfied.
Yeah, now it is.
Yeah, now it executed actually.
Now change the clusters.
Now directly going to visualize the cluster.
I'm changing it to 3.
It is working.
Yes. It worked.
Now visualize the cluster using 3. That means you have to remove that. I think 3 and 4 and 5.
Yeah.
Just
No,
cut
0,
them.
1, 2 only should be there. 3 and 4 should be removed.
That means 4 and 5. Yeah. Cluster 4 and 5 not visible.
How to comment this out? Just put
hash.
hash.
Hash. Yeah.
Yeah, now I think we can execute, right?
This. Okay.
Yeah. 1, 2, 3. 1. Yeah. Now red is become more.
So yeah, that is why they just maybe try with 4. This is 3, right? 3 clusters.
Yeah, this is 3 clusters.
Okay. So and then try 4 and then try 5. Maybe after that try 6. And then you come to a conclusion where it is getting accurate.
It's going with the trial and error only. As in.
Yes. Always it is going to be a trial.
That PKA means like we see in the elbow method, right? So elbow method.
Elbow method. Here it is a ward method. The linkage between the distance, it is a ward method. So the K means for that is the elbow method. Elbow method is really very useful method also.
Yeah, this is 4 clusters.
Okay. So this is also here
5.
and there,
If we add 5, now that corner also, the corner red will become another color.
Yeah.
Yes, this corner will become, yes. Let me change that to 5. Correct.
So, yeah, this looks a perfect cluster. If you want to, okay, try with 6, then, let's try for 6.
This will become separate like this.
Ah,
We will
yeah,
try. See, you
that is the
will see.
possibility.
But that will be the data points are very less. Suppose if
Yeah.
you add more cluster, no,
Mm.
that
Yeah, that is.
maybe
Mm.
we have to add one more thing. Yeah, different color can give from orange or
Will become 5, 4,1 is 5,1, magenta, red, blue, green, cyan, violet.
yellow. You can give.
Okay.
6 cluster 6.
Cluster 6. Yep. Yeah, as expected.
Yeah.
Little bit more points it took. Yes.
So yeah, this is one of this is how we have to decide. So we don't want too many clusters. That is also we have to consider, and at the same time we don't want less clusters because for same kind of finding out the k. Right? So we have to be always optimum level cluster things. So for that you have to
This
first
the Amazon festivals are coming now, so they're using
yeah.
this clustering techniques in a very detail.
Yes,
So
very detailed, in depth.
yeah, in depth. So and you will get the product, especially in the location based. So in a very
Yes.
high discount. I actually evidenced it. I checked the same product in the different location. The price is getting changed actually.
Okay.
So it is not like first ask them to check if it is the pin code. Okay. So if the pin code is not, the pin code is changing, the rate is changing.
Okay.
So they are trying to give offers based on the clusters. So particular, the regions are clusters for them, for example.
Exactly.
Yeah.
Okay. So we'll go for another thing. Exciting for another algorithm. Yeah, go there. Open that sheet or folder. There you can see the structure. I want to see what is the no, not here.
MI, yeah?
ML.
ML, okay. Course material you go.
Yeah. Okay. Classification done, clustering done. Yes. Now,
Association rule learning.
okay. Super. It is really a nice topic.
Priori. What is that?
A priori. A priori. Rule learning.
Okay. Shall I upload this?
Yes, please. So now we are slowly getting into the deep learning module.
So this associate rule learning comes
under deep learning. Yeah. The basic machine learning got over.
Till clustering the basic machine learning. Okay.
Yes. Now you are entering into the deep learning module. Okay. So now we will get slow because of there are so many other things we need to work on. Now it is not going to be the structured learning process. There will not be any kind of a structure going forward. like what we
Oh.
have seen. Yeah, what we have seen in the basic machine learning. No, so we will take a lot of examples. We will just deal with a lot of libraries. Okay, so before going into the so we'll start the association to the learning. What is it and everything. Okay, so I will share. Okay, so you just try install. Just execute one by one.
Apriori.
Yeah. Next.
Yes. Installed.
Yeah. Next. You install that particular library.
Yes.
NumPy, Matplotlib, Pandas.
Pandas.
Next one.
Yes.
Now the data is getting pre-processed. Okay. Now we need to look at the data set. So open up the market basket optimization data set.
Error.
Maybe in a separate just huge.
Separately I should open.
Yes, yeah, please. Right.
Yes. Yeah.
So just to play around the data, I mean information. What is that information is all about? And what are they discussing about?
It is all about groceries.
Groceries.
Looks like supermarket data or a vegetable market. No, it's supermarket only because I can see oil, rice, pepper. So
It is like individual purchasing the groceries. See, for example, first row, we go one data will be there. Second row, we go burger, meatball, eggs. It's not in order.
these
And also, whatever the purchase list.
every customer's individual purchase list, or it could be one customer's purchase list, like for different dates or different visits. Because here we do not have anything about the customer, so we cannot say if it is one customer data or it is multiple customer data. But this is the
Huge data is there. It's very huge data.
Huge data, right?
these are the items or orders procured by the supermarket over the course of time.
Okay. Okay. So you got something about the information, right? Okay. So I will share. First, we'll go, what is association rule learning. Before going for the association, we need to learn what is rule learning. Okay. Maybe open up a new tab, Sai, from yourself. Start.
What should I open?
Open a new tab in Chrome, Google Chrome.
Chrome.
Type. Yeah. Go to Google search engine. That's what I do. Go to Google search engine. Association rule learning. Association
Rule learning.
Learning is machine learning. Okay, come down. Yeah, medium. There is one medium, right? So, yes, click that. Let's close this. No, they're also given the same thing. Okay. Okay, come back. So it is unsupervised. Go up. No, go up. The first. Yes. So we'll start from the first.
Okay. We'll dive into our specific.
Yes. Yeah. So before, what is, unsupervised learning. Yeah, if you see the data set, you got to know that that is unsupervised, right? The training data is unlabeled. Yes, we don't have any kind of a labeled information, unordered, unstructured. All the things, it got satisfied, right? That is, the system tries to learn the information without a teacher, right? So association rule learning is an example of unsupervised learning. It is used in market basket analysis, intrusion detection, web usage mining. That is how, how the traffic is for your website, or how the user is using the web page, that kind of an analysis. Okay, even, if you recently, all the service provider, like Airtel, Geo, the major players, right? They have introduced the technique called, if you use any unwanted websites, it will just give you a pop-up information. Okay, don't use this kind of website. Don't go into this kind of information. Or they have the personalized information, personalized browsing history. That is also possible these days, just for the information, because they also, have the tag on those things, tag or flag or whatever it is. Okay, if government wants, just in case, based on your number, they can trace out what is your, recent search, or what is the history of search. So this algorithm's goal is to dig into large amounts of data and discover interesting relations between attributes. Okay. So the association rule learning, this is really an interesting subject. Okay, I will give you an example. Okay. Maybe from childhood, you are just, growing by observing too many objects, too many places, too many images, too many visuals, right? Through your eyes, through, and then there are, human behaviors, patterns, human feeling, and everything. It's a collective, in nature, and you have lot of things in your brain. Okay. So the thing is, if I say, um, um, what do you mean? I can question. Okay, if I say ice cream, okay, so let's say ice cream. I just said that, the word ice cream. Immediately, your brain is recollecting all the associated informations, associated instances, associated situations, embarrassment, or happy moments with respect to ice cream. To me, I just, first saw the ice cream when I was walking down the streets of Kekenagar. I was, around maybe 8 years old or 9 years old. I just vaguely remember the age, but that is still I got to know. If you say ice cream to me, my brain or my memories goes, just, just walk down the lane of, scenes from I just first saw, where I saw the ice cream, and what is the flavor, and what is the smell at that time I had. Along with that, I got to remember. Okay. It is a really surprising thing. In our brain, we have some memory. In that memory, we have, we had, see, we had so much of information we are dealing with on a day-to-day basis. But if you say one information or one word, your brain is thinking, or your memory is just, getting to know all these informations with respect to this. That okay. Similarly, if I happen to hear some songs. Okay, in my life, certain songs I never listen during the night time, and that will spoil the entire night. Okay, because it got reminded of my golden age and golden period, golden moments, and I want to go back to that, but that is not at all possible, right? So that is why I couldn't. I mean, I don't want to listen to those kind of things, especially at that time, during 80s. Okay, there are so many movies, and if I got reminded of any songs, okay, say for instance, um, I think in Mudal Maryada, I think the same has been dubbed into Telugu as well. Okay, Mudal Maryada song, if I were able to remember, I mean, got to know or got to hear those things, and immediately I got to, I gone back to my that kind of an age, and at that time I was, fishing a lot of fish along with my friends, childhood friends, and that has, I mean, not only that, there are so many other memories as well, comes into my mind, and that is one kind of a collections. And not only those things, after that, what happened using, I mean, how many times I used to hear the song, and in what are all the other instances that are related with this song, I mean, by hearing this song, and what kind of an emotions, I have got through, hearing these songs, and the entire, the day or the entire night, I got reminded of these kind of things. This is exactly the associative rule learning or associated rule learning. It is just, getting associated with each and every element. If I say any kind of a sweet name, right, you got reminded of when you just, had that kind of a precious moment, right? When did you enjoy that last moment? So this is really an interesting, and we never know where it started and where it goes and where it is getting stored. You never know, because there are so many billions and billions of neurons in our brain. Okay, so here we are just using this technique just for the unstructured into structure and unordered into order or unlabeled into label. That is only one thing, right? But this association rule learning, actually, it's a huge or big topic, which is never ending process in deep learning. Okay, never ending. And and finding out this kind of each and every moment, every researchers they are spending to make it, maybe one instances they are making one algorithm, one I mean, one associated I mean, information, they are just making it another algorithm, but still they couldn't get those kind of information into a live process, and that's still under progress. Okay, that is very very tough to get into the the smartness into AI, but still this process is really very very interesting process, and this is how, without association rule learning, we never live. And I mean, our life is, I mean, it won't be interesting, because since we three met, because I associated with Sendil associated with Sai, and Sai now is associated with me, and this is all three of us, we are discussing a lot of things, it is almost 25th or 26th class in our AML journey. And think about it, and how many instances we have discussed. And whenever you are just happen to see any algorithm, it got reminded of what all the things we have discussed. It is like, Inception movie. So a dream in a dream in a dream, same like, the machine learning, in that machine learning, our life is also in that machine learning, and vice versa. Okay, so what I'm just, trying to say, this association rule learning, this, you are in this process every day, every moment of your life. Okay. So this is the basic of whatever we are going to see in the near future of the deep learning processes. And please try to observe what is happening hereafter in your each and every step of your learning process. And also not only the learning process, whatever you are learning over here, and try to observe in the real time what is happening in and around your life, your official work, your personal work, and how everybody is at home, how everybody is at in your office, maybe under your team, in your leadership, how people are behaving. If you started observing, and slowly you are getting into some other processes, maybe you will be able to reduce your pressure, you'll be able to reduce your anger, you can control maybe you can do the anger management also, right? If you slow, this is like kind of a meditation, I would say. People will say that if you do meditation, you just getting into balanced work life or something, some sort of things, right? I still have a lot of questions around that, but still, if you learn this association rule learning, literally, you can do a lot of wonders in your observation capacity, and that observation leads into a lot of our uh, progress in your life and growth in your life, maybe personal life or and also the other career life. Okay, so yeah, this is what we are going to. I think you got the point, the essence, what is called association rule learning, how it is getting. This the same thing. If you just come down, if you just see the image, come down, come down. Yeah, this is the image. Yeah. How does association rule learning works? If you just see um, how it is, it is getting related one another or each one. Okay. Um, just see the information which has been portrayed, and then
Tropical fruit, if they are typing suggestions you are getting
mm,
for whatever will go with it. For example, if you see canned vegetables, grapes, processed cheese, so you can
mm,
prepare whatever ingredients you require to eat with it or to prepare something with it. It is actually suggesting or forming a
okay,
class. For example, here, if you are seeing liquor, for that appetizer in the bracket, it is showing. Then
mm.
canned beer, it is showing. Male cosmetics, it is showing. I don't know why male cosmetics is shown here. Uh,
Okay.
yeah, bottled water. So for
Mm.
liquor, canned under liquor, like what is your choice? Like it could be a canned beer or it could be
See,
something else, or along with liquor, you require bottled water. So the same thing with the milk here. If you see, if somebody is ordering milk, cereals is
Mm,
suggested, rice is suggested,
mm.
then yogurt, soft cheese, all this like cluster within cluster
Okay.
they are creating.
Okay. Now we will see one by one. Go up. Right. So why do we use association to learn? Right. So yeah, you are the owner of a supermarket and you want people to buy your product easily. What you can do, you can run this algorithm, sales log, and find interesting relations between the items. Right? Okay. So you may want to do the following things if you are running a supermarket. You can place milk, bread, and butter on the same shelf, so
Hmm.
that buyers of one item would be prompted to buy another item. See, the same kind of, I think this we had discussed. How if you order an item or multiple items together on any e-commerce portal, any grocery portal. how their shelf would look like. Forget about the real supermarket. We experienced that. But what we may not experience nowadays, what they are having the luxury of getting the delivery, right? Wherever you are and you are making an order, how quickly they are delivering those products. Maybe take it as a homework for tomorrow's. Okay. How Zepto is maintaining their inventory, how the the similar e-commerce portal, how they are maintaining the
Blinkit.
Yes, Blinkit and the other, Big Basket or even Instamart, Swiggy, they are also having Instamart kind of things, and how they are maintaining their inventory based on the association rule learning. Okay. The second point is you can put milk, bread, and butter on discount to increase your item sales. These are all the business concepts, and also the not only the business concept. This is also one of the you know there is an association towards it, towards the process. The third point is you can also target the buyers of milk or bread with the advertisement of butter. Maybe next time if you are going physically, just look around based on this association rule learning. How well you are connected with this association rule learning. Okay, it's really you will get some kind of an input. You will
No,
get some
actually, I
kind of
surprised. After seeing this, I surprised actually. So I used to go for egg, okay, buy the egg, and the milk products are placed near to that. When I take the milk, now immediately the bread section is next to that. And the bread section next to is the butter, those are butter and the ghee and this one. What is that? Butter.
All
But
milk
everything, all milk products. I'm surprised. This single row, you can purchase. I mean, you grab all the things, whatever we want. So now I trying to connect actually.
Yeah. So what we had discussed initially, that is the memories and how brain is storing memories in our neurons. The similar kind of a concept we are just bringing together with the products. Okay, so product we got the 100% results, the smartness we have built around this, but the same kind of a concept we are trying to build around with brain. So let's see how when we started the full string on deep learning and how it is getting matter. The fourth point is you can also combine bread and butter into a whole new product, that is buttery bread with slightly milky flavor, and then put it on sale. So not only in increasing sales, association rules can also be used in another fields. For example, in medical diagnosis, understanding which symptoms tend to tend to comorbid can help to improve patient care and medicine prescription. Okay, so this association, this is what I was trying to quote there. Okay, come down. How this learning works. This algorithm counts the frequency of complementary occurrences or association across a very large data set with over thousands of attributes. So the goal is to find associations that take place together far more often than you would find in a random sampling of possibilities. Okay, so from here onwards, you can find the possibilities, probabilities, because those are all the instances. These are all the non-definitive statements. Okay, this will happen, that will happen based on the historical events. We are those kind of things gone, and we have gone through those machine learning processes. But here, what would be the probabilities? What had happened if that is not the? I think one of the movies in Tamil, 12B, I guess. If until the first half, the story just goes towards one phase. The next phase, the next section, the second half of the movie, if that was not the case, then what will happen? Based on the probabilities they have taken in movie. So did you remember this movie? 12B movie?
Yeah.
Yeah.
Is the
Yeah.
story goes like if he catch the bus, what will be
Yeah.
the story, and if he miss the bus, what was the story? Yeah, we try to interconnect both the points.
Yes, that is also one of the association-based learning methodology in machine learning. And if you were not a SAS programmer, what you should be or what you would have done? If you are a SAS programmer and if you are a machine learning engineer in future, what you would do in future, right? So there are so many things.
If I have not met you in what is that 15 years, 16 years back, like I met you in your home that time.
Yeah,
So you
yeah,
given me a little SAS book. I remember.
yeah.
So if that day has not happened, I was not aware. I'm not into that field.
Right.
So it's so much of interconnection. Mm.
Yeah. So the goal is to find associations that take place together for far more often than you would find a random sampling possible. So to measure the associations between thousands of data items, there are several metrics. And to support this, the metric is called as support metrics. This says how popular an item set is. That is, it is used to find the frequency of a certain item set appearing in the data set. Okay, the support. And then the confidence. Confidence, this says how likely item B is purchased when item A is purchased. Okay, so these kind of I think if you remember this, when you are a frequent buyer in nearby supermarket, every month or twice in a month, you are that nearby supermarket, the appearance, just they wanted to maintain something very fresh. For that, they change the order of the items. Okay, order in the sense maybe last week or last month, one particular item just got in the middle. Now you will be getting in the beginning of the entrance of the supermarket itself.
Yeah, that is actually the big thing. Like it's marketing, positioning of the product
Yes.
plays a major role, and
Yeah.
they have to pay more actually. So even if they want to display it in any corner or something attractive to the consumers, so they have to the particular brand has to pay to that supermarket. So they try to put it in the shelf. Okay, that's not a problem that they don't need to pay anything, but they want to put it in a very specific angle, specific sections they have to decide. So that
Right.
positioning for that, I think, be cost for the supermarket. So they will, okay, market advertising. Okay, this is all the positioning area where you can display your product so that you have to pay this much amount. So that is actually one of the part of the marketing area.
Yes, exactly. So that is so every now and then there is a frequency towards it. So they will just change the appearance, change the marketing strategy. Even the product owners, they will come to their supermarket and they will pay, like what Sandy said, they'll pay more towards they will just pay attention to the product. Okay, so that is what this confidence, likely an item, one person by item B is purchased when item A is purchased. How many frequency? I mean, if you are buying an egg, ultimately you are trying to buy bread. If you buy bread, ultimately you buy milk. If you buy milk, ultimately you go for cheese or butter for the bread, right? So this is kind of associated with one another. Okay, so there is a matrix towards this support and confidence and lift. This says how likely an item A is purchased while controlling how popular item B is. Sometimes, if you are a frequent buyer or a constant usage of a particular toothpaste, and after some time, you won't get that product in that particular supermarket. Did you observe this? Not only
Yes.
toothpaste, any products. So I was using, I used to, go for a strong teeth or strong tooth Colgate toothpaste, right? But this paste has been changed or not marketed nowadays because they want me to buy a different variety on the same Colgate brand. Okay, so that means the strong, the market of that, it is just which is very very. I mean, it could be multiple reasons. They wanted to attract the young generation. They wanted to retain the older ones. There's so many other things, but still, who is who is the buyer of the product, or who is spending more money? That way, that's how their manufacturers they will think, and they will just go for it. Okay. So lift has three possible values, right? Lift equal to 1 minus the probability of occurrence of A and B is the independent of each other. Come down, sorry. Yeah. Lift equal to 1 minus the probability of occurrence of A and B is independent of each other. That is one possibility. Next, lift greater than 1 minus it determines, it determines the degree to which A and B are dependent on each other. If lift equal to 1, the probability of occurrence of A and B is independent. So lift is greater than 1, it determines the degree to which A and B are dependent on each other. Lift less than 1, it tells us that A is a substitute for B, which means A has a negative effect on item B. So when it comes to the the requirement, we'll discuss in detail data set. Come down. So different types of association we'll learn. So in association, a priori algorithm, ECLAT algorithm, FP growth algorithm. So a priori and ECLAT are frequently used. FP growth, not much, but maybe I couldn't see much of the frequency. Only a priori, that is very known algorithm in the machine learning and deep learning, and ECLAT is somewhere the financial sections and other things in this story. Okay, so this a priori algorithm uses frequent data sets to generate association rules. We apply an iterative approach or level-wise search where k frequent item sets are used to find k plus 1 item sets. Here also, you are getting the k value. So this algorithm uses a breadth first search algorithm and hash tree to calculate the item set efficiently. So what is breadth first search and hash tree? So these are all the things we need to explore more and then come into the a priori. Now we have, if you just open the a priori algorithm, yeah, the code. Now just go through the code. What is happening?
We just installed and then imported. We have
Okay.
got data here.
Okay.
Um,
So they are taking the range
yeah.
0,7501. The transactions dot append a string of dataset dot values I comma j for j in range 0, 20. So just how they are taking the value from that particular dataset. So they are taking only few items, few information, and only they wanted to get processed and get and give the training for that model. So let's see. This run. Yeah, it is run.
Now we are training the data set.
So APYORI, it's a separate library. It is not just we had done previously. It is a separate library. You are importing in that API ORI. You are importing a priori. You have to just make a differentiation. You are importing a priori. Rules: a transaction equal to transaction, comma min underscore support equal to 0.003. Minimum confidence 0.2, min lift 3, min length 2, maximum length 2. So this is what we have just crossed, how the lift is working, how the support is working, how the confidence is working. All these things, the minimum value is there and the maximum is there. So you are giving, yeah. Now you are just visualizing the results, list of rules. Okay. So what is the results saying?
Printing the results.
Different, yeah, results. Okay. Oh, okay. So this is the relation with that association. So if you see the results, just go up, go up. Just to see the results. So
Yeah, right.
relation record items, yeah. Pros and
Two
cons.
items it has displayed actually.
Right, exactly. Light
Kilo
cream, chicken.
cream sauce.
Okay.
Escalope mushroom cream sauce, pasta escalope,
Hmm. So
fromage
it
blanc.
is, yeah, it has major association towards that. So that
Yes.
is why they are just displaying
So it
this
is 2
information.
2 because our minimum length is 2
Two,
and
yeah,
maximum length is 2. That is
two,
why it is only displaying 2 products.
yes. Then putting the results well organized into a pandas data frame. Now only pandas is coming into place. So we are used, yeah. We saw the triple list dictionary set in Python, right? So
Mhm.
here they are using it, and the other basic machine learning they never use those kind of things. There's no chance. Here there are a lot of chances using the Python data frames. Okay, just run that code. Yeah. So LHS, RHS supports confidences, lifts, and everything. They are getting into the perfect format. Now we are displaying the results non-sorted. Results in data frame. Okay.
Yeah, all the ones which
Yeah, all the things they are just making it
uh,
as a table column.
left hand side this one, right hand side this one, support, confidence, and lift.
Okay.
Here I see 3
Hmm.
icons. This is
Okay.
table format, this is graph format, no?
Okay. Okay. Yeah. Suggest graph. Okay. Yeah.
Okay.
Right. So this is
Oh, so many graphs it is
so
giving.
many graphs. Yes. Yes. So many graphs. How it is getting associated with commander.
2D distribution values. Okay.
So now it has the results has been sorted by descending.
Hmm. Descending of what?
The previous one. So the previous one, the light green. Now it is from the top to bottom or bottom to top. So that is
Confident.
yeah.
Confidence based on confidence and support. It is
Okay.
sort.
Data
But
frame n largest n equal to 10 columns lift. Okay. So based on the lift, this
oh,
not
based on lift. Okay.
based on the lift. Yeah.
Yeah, if lift is large, on top it is
Yes.
coming.
Yeah. So
Okay.
this is
Probability of buying that product. Lift is.
income. Yeah, there are so many idea you will be getting if you just take a
Mm,
look at this.
yeah.
Maybe what you can do, just a search on GitHub, for association rule learning projects, so that maybe for a real time case study. So you can just take something and then try to do that.
Market basket analysis.
Uh,
Major, I
it-
think it is
yeah,
supermarket.
supermarket. Yeah. So, so you take whatever, maybe, it has to be different from what we have seen. So it's up to you.
How we have done market basket.
Yes. So you can take any other things and we just, maybe by coming tomorrow, we take it as the word, how you are going to do, and then we'll see.
Sure. Yeah.
So with this, maybe we can stop here and then we'll continue to.
Sure.
So any questions?
No.
Okay. Okay. So we'll move tomorrow. Take care.
Isn't it?
Thank you.
Yeah. Thank you. Have a great day.
Bye bye.